For those of you who loved Q, here we go. So now what we're going to do is we are going to predict whether a precipitate will form or not. And the key concept here is that we are going to be comparing a trial ion product Q to the known KSP and deciding, are you like going to form a precipitate or not. So it's a little bit different than KEQ and Q, but I'll explain it. So KSP, just to make sure you understand the concept behind it, is that KSP is the maximum concentration of ions that a solution can hold before a precipitate forms. So when we say something has low solubility, it can hold a certain amount of ions in solution until it won't dissolve anymore. Or on the flip side of that, when you introduce ions into solution, it'll hold a certain amount without precipitating. But when you reach a certain, what's the word for that? A certain amount, right? All of a sudden you will precipitate. And so we're going to be using a trial ion product to determine, are you at the place where a precipitate will form, or are you under the minimum KSP value, meaning that you can remain ions in solution? So a good example of this is calcium carbonate, right? Calcium carbonate forms calcium and carbonate ions, and the KSP for this is calcium ions times carbonate ions equals 5.0 times 10 to the negative 9. That's KSP, right? That would come from the sheet. This is the maximum product of your ion concentrations. If any more calcium or carbonate ions are added to the solution won't be able to hold them, so a precipitate will form. So KSP is like your max amount of ions that can be held in solution before a precipitate forms. So the rule is, if your Q value, if your ion product constant is greater than your KSP, the solution can't hold that amount of ions, so a precipitate will form. If Q is equal to KSP, you're saturated and you're on the verge of precipitating. So, maybe a precipitant will start sort of kind of forming, but maybe not. You're right on that cusp anymore and you're going to start precipitating. If the Q value is less than KSP, then the solution is unsaturated and a precipitate will not form. So just a couple notes. The solubility table is a guide, but it's not a guaranteed precipitate if the ion concentrations are too low. So what I mean by that is when you're looking at your information booklet and not the KSP sheet, but this sheet, every time we've said low solubility, we've said a precipitate will form. But that's only true if there's enough ions to precipitate. So low solubility means that your solution can hold a certain amount, but once you reach that value of KSP, you will start precipitating. So the other one is that even if the table predicts a precipitate might not form, right? If the actual ion concentrations are below KSP. So it's pretty much saying the exact same thing twice. So what are we going to do? Well, we are going to predict if a precipitate will form. So will a precipitate form if 25 milliliters of 4.5 times 10 to the negative 3 molar lead nitrate is mixed with 35 milliliters of 2.80 times 10 to the negative 3 molar magnesium iodide? So the first thing you want to do is see, is there a potential precipitate? So the ions that are present are lead, nitrate, magnesium, and iodide. So if you think about this as a double displacement reaction, you're either going to get lead iodide or you're going to get magnesium nitrate. So the magnesium nitrate definitely will not precipitate. So the magnesium nitrate is soluble. Right? If we look on the solubility table, it would be soluble because it's with nitrate. But let's look at the lead iodide. So if I go to that table, where'd it go? If I go to this table and I look up lead iodide, I'm going to go iodide with lead has low solubility. So up until this point, we've been like, yep, precipitate will form. But that's only true if there is enough ions in solution to precipitate. So the only possible precipitate is the lead iodide. The dissociation equation of lead iodide would be lead iodide solid would dissociate in an equilibrium equation to lead ions, aqueous, if I'm being proper, and 2 iodine ions, aqueous. Okay? So then what we'd have to do is say, okay, well, we have to find the concentration of lead and iodine so that we can multiply them together to find a trial product constant to see if it will happen. So because there's mixing, there's dilution. So what we would need to do is find the concentration of lead ions in solution and the concentration of iodine ions in solution first. So to find the concentration of the lead ions, this is the lead nitrate, right? So the lead nitrate up here was brought into solution, and it was 25 milliliters of 4.5 times 10 to the negative 3. Now, lead nitrate dissociates into 1 lead ion and 2 nitrate ions, so it's a 1-to-1 ratio. So it's going to dissociate to 1 lead ion, which is the 4.5 times 10 to the negative 3 molar. Then we want to do the solution dilution. So there's 25 milliliters of the lead nitrate getting mixed to a total volume of 60 milliliters to give us a concentration of lead ions as 1.88 times 10 to the negative 3. But of course, we're keeping that unrounded value in our calculator, right? We're just keeping track of our sig figs. Then we do the same thing with magnesium. Now I just realized that this 2's in the wrong spot. I'll fix that. So it's magnesium iodide would dissociate into magnesium and 2 iodine ions. So it dissociates to 2, meaning that the concentration of iodine ions in solution would be that 2.8 times 10 to the negative 3 times 2. And then we would do the solution dilution. So there's 35 milliliters of this mixture diluted to a total amount of 60, which would give us 3.26 times 10 to the negative 3. But again, we're going to keep unrounded in our calculator. So now what we would do is we'd find Q. Q is equal to, back up here, the concentration of lead times the concentration of iodine squared. So we're going to put in the 1.88 times 10 to the negative 3 times the 3.26 times 10 to the negative 3 squared, which would give us approximately 2.00 times 10 to the negative 8. I just did a quick check on my calculator because it came out to, like if you're not in scientific mode, it came out to 0.000002. So then I changed to scientific mode and I did get 2.0008. So to 3 sig figs is 2.00 times 10 to the negative 8 is my Q. So then what I want to do is I want to compare my Q to my QSP. Now the KSP for PbI2 or lead 2 iodide is 8.5 times 10 to the negative 9. So the Q value of 2 times 10 to the negative 8 is greater than the KSP of 8.5 times 10 to the negative 9, which means that a precipitate will form, right? So there was a lot of work in there. And that's what these questions are, unfortunately. There's a lot of work, but it's nothing too crazy. It's just a lot of steps. So let's do another one together. So this time we're going to have calcium nitrate mixed with sodium carbonate, and we're going to determine if a precipitate will form. So the first thing we want to do is figure out what is the potential precipitate. So we have calcium nitrate mixing with sodium carbonate, right? Maybe I'll write this above. I don't want to run out of room. So you have calcium nitrate mixing with sodium carbonate. My potential products are calcium carbonate and sodium nitrate. Now I don't need to balance this, but it's going to bug me if I don't. Okay, and so the only potential precipitant is the calcium carbonate. So let's all of a sudden, or not all of a sudden, let's first check to make sure that that is a possibility. So calcium carbonate, we're looking at carbonate is low solubility with everything except for those basic ones. So this is my potential solid. The question is, will a precipitate form? So calcium carbonate will form calcium and carbonate ions. So what we need to do is find the concentration of each of these ions so that we can find the trial KSP, or the trial ion concentration. So the first thing we're going to do is find the concentration of calcium. So the calcium is coming from this mixture. Now, if you're not sure, calcium nitrate would form a calcium ion and 2 nitrates. So the molar ratio is that the concentration of calcium will be the same as calcium nitrate. So it's going to be the 0.0035. And then we're going to do the solution dilution. So we've got 50 milliliters being diluted with 150. So we'd have to 200. And we're going to plug that in. So 0.0035 times 50 divided by 200. Oops. Hit a weird button. Decimal 0.0035 times 50 divided by 200 gives me, I'm just going to do it in scientific notation mode because my calculator is still in it, 8.75 times 10 to the negative 4 molar. Then I'm going to do the same thing to find the concentration of carbonate. So sodium carbonate forms 2 sodium ions and 1 carbonate ion. So again, my molar ratio is going to be the same. So my concentration of carbonate is going to be the same as the sodium carbonate, which is 2.0 times 10 to the negative 5. And then we're going to do the solution dilution. So this one's starting with 150, diluted to a total volume of 200. So I'm going to do 2 times 10 to the negative 5 times 150 divided by 200 gives me 1.5 times 10 to the negative 5. Then we get to move on to the Q. So Q is going to equal the concentration of calcium times the concentration of carbonate, which is going to be 8.75 times 10 to the negative 4 times the 1.5 times 10 to the negative 5. So times 8.75 times 10 to the negative 4 gives me 1.3 times 10 to the negative 8. Now that's my Q value. So then I have to look up KSP. The KSP of calcium carbonate, I have to scroll down. So calcium carbonate has a KSP of 5.0 times 10 to the negative 9. So since my Q value is greater than my KSP, therefore a precipitant will form. Oops, that's not a very good word. Form. All right, it's not easy. It's definitely not easy, right? But now can you pause the video and give the next one a go? So follow mine as a model, right? Think about what I did. The first thing I did was figure out which ions I need to find the concentration of. Then I found the concentration of both of those ions. Watch your mole to mole ratios. Then I use those concentrations to calculate my trial ion product constant. And then I compared my KSP to my trial constant to determine if a precipitant will form. So if you're feeling confident, feel free to pause the video and give this one a go. Otherwise, you can keep watching and I'll do this one with you as well. So the question is, will a precipitant form if 20 mils of 0.01 molar calcium nitrate is mixed with 20 mils of 0.008 strontium hydroxide? So the first thing you want to figure out is what is your potential precipitant. So I know it's not going to be the strontium nitrate, so it's going to be calcium hydroxide. And if we double check, and we go back up here, calcium hydroxide is definitely low solubility. So let's go for it. So I'm going to say that calcium hydroxide is going to dissociate into calcium ions and hydroxide ions in a 1:2 ratio. So then the next thing I need to do is I need to figure out my concentration of calcium and then my concentration of hydroxide. So my concentration of calcium is going to come from here. It's in a 1:1 ratio. If you're not sure why, right, you can write your dissociation or your ionization equation. It's not dissociation. Well, yeah, it's a salt. So we've got calcium 2 plus and 2 nitrates. So it's going to be in a 1:1 ratio. So the concentration of calcium is going to be the 0.010 molar. Then we're going to do the solution dilution. So it's coming with 20 milliliters and it's going to be diluted up to 40. Oh, this is going to be nice numbers. So we've got 0.01 times 20 divided by 40, or just divided by 2. I'm going to put myself back in normal mode. And I get 0.0050. Then I'm going to do the same thing to find the concentration of hydroxide. So we've got strontium hydroxide is going to dissociate into strontium ions and 2 hydroxide ions. So it's going to be a 1 to 2. So the concentration of hydroxide ions is going to be 2 times the 0.0080 times the solution dilution. So it's also 20.0 divided by 40.0. So I've got 2 times 0.008 times 20 divided by 40, which gives me, look at that, 0.0080, right? Times 2 divided by 2. Okay, so then we want to find Q. Q is equal to the concentration of calcium times the concentration of hydroxide squared. I often find I don't want to put my numbers in. It just feels like so much more writing. So, I mean, I've clearly laid out that the concentration of calcium is this, the concentration of hydroxide is this, so I can just put them in, or you can write it. So 0.0050 times 0.0080 squared is going to give us 3.2 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. Just checking my answer to make sure I didn't mess anything up. It's kind of nice to like have an answer key you've already done to be like, did I do okay? All right, so then we have to look up KSP. The KSP value for calcium hydroxide, oh right, isn't on the sheet, so I gave it to you. So the KSP is 5.02 times 10 to the negative 6. So for this one, the Q value is less than KSP, so there's not enough ions in solution for a precipitant to form. So you will say precipitant will not form unless we add some more ions. All right, hopefully that is feeling okay. We only have one more type to go, so they're not nearly as hard as the Unit 2 questions, hopefully you're finding.